In the last part of the semester, we're going to take all the tools that we have learned thus far and apply them to different types of equations. The first type we're going to look at is rational equations. You might remember we had rational expressions. We learned how to reduce them, add, subtract, all of that stuff. Now we're going to apply some of those ideas to the equations. So the first step we're going to do is find that LCD, that least common denominator of all three terms. And we're going to multiply every term by that LCD to get rid of the fractions to make our equations easier. Then we're going to solve. That may be just getting x by itself. It might involve some factoring. But then here's a new part. We're going to have to check for extraneous solutions, meaning because we started out with some variables in the denominator, we have to be careful to make sure that our answer does not cause us to divide by zero. Dividing by zero is undefined in our math world, so we would have to throw those answers out. And you're saying, wow, that's a lot to remember. We'll get there. Let's just go take it a step at a time. So let's find the LCD. Well, 6x, 8x, and 12. Between 6, 8, and 12, the LCD, I believe, is 24. And then, of course, we need the x. So we want to multiply every term by 24x. And remember, that's like over 1, so we can reduce. All right, that's what we're going to do. So 6 goes into 24 4 times, and the x's cancel out, and we would have left 28 minus the x's cancel. 8 goes into 24 3 times. I'm going to multiply that together. We get that negative 15. And then we have 12 goes into 24 2 times. Don't lose the x. Multiply all that together, and we get 26x. So we've gone from a very scary looking equation to something very easy. So let's go ahead and now solve. 28 minus 15 is 13. We would divide both sides by 26, very basic algebra, and we would get x equals, not 2, 13 is smaller than 26, it's 1/2. Then we have to check for extraneous solutions. So what would cause this denominator to be 0? Well, if I put 1/2, 6 times 1/2 is not 0, and that's all you need to know. You should know it's 3, but you should know it's not 0. If I put in 1/2 here, 8 times 1/2 is not 0. There's no x here, so that's an okay answer. It is not extraneous. Let's look at the second example. So again, we want to find that LCD of all the denominators. Well, it's obviously 12. We have an x and an x squared. Remember, we keep the factor to the highest power, so it's 12x squared. So I want to multiply every term by that 12x squared. Then I'm going to reduce. The x squares cancel, and I'm left with 12. Don't lose the minus sign. The 12's cancel, and only one x cancels. So I have minus 1x equals, the 12's cancel, and I have 1 times x squared, which is just x squared. Now notice this is a quadratic. How do I know that? Because of the x squared. So I'm going to have to set it equal to 0 in order to solve. Now, I like my x squares positive, so I'm going to add x to both sides and subtract 12. So I'm going to have 0 equals x squared plus x minus 12. And I'm going to need to factor that because it's quadratic. And I believe a plus 4 and a minus 3. We set those both equal to 0 and solve. And so this time we have two answers. And again, we must check both answers back into the denominator. So again, let's look at those denominators. X squared. If I put negative 4 squared, that is not 0. 12 times negative 4 is not 0. If I do the same thing for 3, 3 squared is not 0, and 12 times 3 is not 0. That's all you're checking, so both of these answers are keepers. And yes, we're going to do an example where you're going to get an extraneous solution. So let's see if that comes up next. All right, looking more complicated here. So we're going to find that LCD, but this time we don't have monomials, we have binomials. So you may remember, it's been a while, in order to find that LCD we have to factor. So that's a factor, and guess what? X plus 2 times x minus 1 is this trinomial. So my LCD is 1 of every kind of factor. And that's what I need to multiply by. So I need a little more room here. So 3 over x minus 1, and I'm going to multiply by that LCD. So when you're writing out these problems, you might write them out a little bit more spacious so you can have the room to multiply every term by that LCD. So let's see what's going to reduce. The x minus 1's reduce, and I'm going to write down what I have left, 3 times x plus 2. The x plus 2's reduce, and I have 4 times x minus 1 equals, and look, all of that goes away, and you just have 16. So notice I've gotten rid of all my fractions, and now I'm going to solve. So I'm going to distribute, collect like terms. I don't have a quadratic this time. Subtract 2, divide by 7, and my answer is 2. Now I have to check for extraneous solutions. So I'm going to plug in, substitute in 2 everywhere there is an x in the denominator. Right? So 2 minus 1, is that 0? No. Is 2 plus 2 equal to 0? No. And since these are the same as the other two, I know those aren't 0. So again, no extraneous solutions. But what if, what if x had equal to negative 2? Now it is positive 2, but what if it was equal to negative 2? Well, negative 2 minus 1 is not 0, but negative 2 plus 2 is 0. So if it would have been negative 2, I would have had to cross it out and say no solution. We got to still check, got to be careful. Right? So LCD. Can't factor that. That's a factor. Ooh, but I can factor that with a GCF. And notice, on this side, usually is going to equal to that. And so my LCD is x times x minus 2. All right, so again, I've taken the time to space it out a little bit more, multiply everything by that LCD. Notice I didn't write it as x squared minus 2x. I wrote it in factored form so I can see what can be reduced. Okay, if you try to squish it all in, you usually lose stuff, so just be careful. All right, so the x minus 2's cancel, and I have 3x. Here, the x's cancel, and I'm going to write that as negative 2 times x minus 2. And I'm doing that so I don't want to lose that negative sign. Equals just 6. All right, so I have 3x minus 2x plus 4 equals to 6. Collect like terms, subtract 4. And again, I get that answer of 2. But I have to check. Where do I check it? Only in the denominators. That's all you're worried about. We just don't want to divide by 0. So if I put in 2 for x, what's going to happen here? 2 minus 2 is indeed 0. So I don't erase, I don't squish it out where I can't read it, just put a line through it, and I'm going to write no solution. Because 2, if I put it back here, it causes me to divide by 0, which is undefined and not allowed. These two problems, they have some asterisks, and that's because we can cross multiply. Anytime you have a fraction equals to a fraction, you can go through the same process, find the LCD and all of that, but it's usually a little bit faster just to cross multiply. Only works if you have one fraction equals to one fraction. So all the other examples this would not apply to. So I'm just going to cross multiply here, not losing my equal sign. So I have 3 times x squared plus x equals, and then it doesn't matter what order you write this in, but it's x plus 1 times 2x plus 5, which means I'm going to have to FOIL. Right, so let's distribute, then FOIL this out. Let's see, that's going to be 5x plus 2x is 7x. You really should be able to do that outer inner in your head, plus 5. And again, I have a quadratic. I like my x squares positive, so I'm going to move everything to the left. So I'm going to subtract 2x squared. I'm going to subtract 7x. Let me do that first. So that's going to give me 1x squared minus 4x equals to 5. I still need to set it equal to 0, so I'm going to move the 5 over and it becomes negative. Then I need to factor because it is a quadratic. And then we set each factor equal to 0. All those things we have been practicing all semester. And then we solve. Okay, are we done? No, we have to check for extraneous solutions. And we check them just in the denominator. So let's see, if I put in 5. 5 plus 1 is 6, not 0. 5 squared, 25 plus 5. That's not 0. So that's a keeper. But what about negative 1? If I plug in negative 1 right there, what happens? Negative 1 plus 1 is 0. So that's what's called an extraneous solution. Or in other words, extra. It works in this equation with no fraction, but it really came from that one that has fractions I can't divide by 0. So my only answer is 5. All right, let's do that cross multiplying one more time. So I have 5 times x minus 1. And again, it doesn't matter what order you write those in. 5x plus 3 times 5x minus 2. So I'm going to distribute. I'm going to FOIL. So let's see, a minus 10 plus 15. That's plus 5x minus 6. And again, I want my x squares positive, so it's easier for me to factor. So I'm going to subtract 5x and add 5. So I get 0 equals 25x squared. Hey, that's 0 too, minus 1. How do I factor that? That's the difference of two squares. And again, set those both equal to 0 and solve. And you're going, ooh, checking fractions. But just keep in mind, you don't have to know what it equals to. You just have to know it doesn't equal to 0. All right, so let's just do it one more time. So 5 times negative 1/5 plus 3. Negative 1 plus 3 is not 0. And negative 1/5 minus 1, again, you might not know what that is, but you should know it's not 0. So that's a keeper. Okay, well, what if I change it to positive? Does that make it 0? No. So both of those answers we can keep. Last example, a little bit longer. You are going to have these on your homework. So let's just take it one step at a time. We can't cross multiply because we have more than a fraction equals to fractions. We have to go back to find that LCD. That's a factor, and that. So I have 2, an x plus 2, and an x minus 2. And I've got to be really careful about that minus sign. So I'm just going to, again, give me more space by writing out the problem. I'm going to put parentheses around everything just to be careful. I know that's very time consuming, but it really will be worth your time. All right, so let's cancel out all the stuff that goes away. And look, you've got a lot of stuff left. All right, so I've got this 2, and I've got 2x plus 4, and an x minus 2. Here, don't leave out that negative. Let's see, I've got that 2. I'm going to put that in front just because it looks prettier, and I've got an x plus 3 and an x plus 2. And here the only thing that canceled out are the 2's, and I've got 1 times x plus 2 times x minus 2. That is a lot of foiling. All right, so, how can I multiply this? I have choices. I can multiply 2 times this, get an answer, and then multiply that answer times that. You just need to multiply 2 at a time. So what I'm going to do is I'm going to keep this 2, and I'm going to FOIL that out. So I have 2x squared. That's minus 4x and plus 4x. Oh, that's 0. Minus 8. That doesn't look so bad. And again, I'm going to keep that minus 2 and FOIL this out. So that's x squared plus 2x plus 3x. That's plus 5x plus 6. FOIL this, and you should know, hey, that's the difference of 2 squares. The middle terms cancel. Now I'm going to distribute those 2's. So I have 4x squared minus 16. Distribute the negative 2. Collect like terms. So I've got 2x squared here minus 10x. That's minus 28. Got to set it equal to 0 because I have a quadratic, so I'm going to subtract x squared and add 4 to both sides. And now finally I get to factor. Okay. Good news, at least the factoring's pretty easy because I know 6 times 4 is 24, but ooh, that wouldn't give me negative. Oh man, that was kind of tricky. Checking the signs, that just didn't work. So 6 and 4 does not work. Yes, negative 6 times negative 4 is positive 24. That's why that didn't work. So what else could we try? 8 and 3? No. How about 12 and 2? That should work. A negative 12 and a positive 2. Negative times positive, multiply to get negative, but add to get that negative 10. So that was a little tricky. So we set each factor equal to 0, and we solve. Still not done. Okay, so we have to go way back up here, and we have to check 12 and negative 2. Okay, 12 and negative 2. So 12 plus 2 isn't 0. 12 minus 2 isn't 0. So that's okay. What was my other answer? Negative 2. All right, so if I plug in negative 2, what happens? That's 0. So I can't keep negative 2. That's an extraneous solution. So 12 is okay, but that one is not. Again, I want to see that on your paper. I want to see just one line through it, and then write the word extraneous. So just to go back over the steps, rational equations, which means fractions, you're going to find that LCD, multiply every term to get rid of the fractions, or remember, if you have a fraction equals to a fraction, you could cross multiply. Don't have to. You could go back to the LCD. Going to solve, but you got to check for those extraneous solutions.